You know that place, Jurassic Park? Ever wonder how in the world they powered an island full of dinosaurs? Well, it turns out the secret wasn't just some crazy genetic engineering. Nope, it was a nearly infinite source of clean power hidden right under their feet. Okay, so obviously Jurassic Park is fiction, right? But the power source they imagined, that is incredibly real. This whole idea of tapping into the immense, constant heat of the Earth itself, that's not science fiction. It's a technology we've actually had for over 100 years. And yeah, when we say the Earth is hot, we mean seriously, physically hot. I love how the folks at the National Renewable Energy Laboratory put it. We're not talking about fashion here. We're talking about physics. Get this. The Earth's core is burning at nearly 11,000 degrees Fahrenheit. That is actually hotter than the surface of the sun. This isn't just a little bit of residual warmth. We're talking about a planetary-scale furnace right under our feet. So this inner fire, well, that represents the incredible promise of geothermal energy. It's a power source that's been radiating heat for 4.5 billion years, constantly, reliably, just waiting for us to tap into it. The scale here is it's almost impossible to wrap your head around. Just a tiny, tiny fraction of the heat that's already inside our planet, 0.1%, could power everything we do for 2 million years. The potential is absolutely staggering. Okay, so the big question is, how do we actually get it? How do we take that raw planetary heat and turn it into the electricity that powers our lives? Well, the process is actually surprisingly elegant. Think of it like a massive natural kettle. First, we drill down to tap into these underground pockets of superheated water. The immense pressure down there sends steam rocketing to the surface, and we use that steam to spin a turbine and generate electricity. And here's the best part. Because the now cooled water is pumped right back down to get reheated, the whole system becomes this continuous, sustainable, closed-loop cycle. And, the technology's gotten way better over time. The very first plant, built in Italy way back in 1904, used what's called dry steam, straight from the ground. But today, we've got more advanced methods like binary cycle plants, which can use more moderate temperatures and run in a completely closed loop with zero emissions. But, and there's always a but, right? If geothermal is this powerful, clean, and constant source of power, it begs the obvious question, why isn't it everywhere? And that brings us to the core conflict in the geothermal story, the groundbreaking challenges. It's this huge paradox, isn't it? We have an energy source that's available 24/7, 365 days a year. I mean, unlike solar or wind, yet it accounts for less than 0.5% of U.S. electricity. So what's the deal? Well, the answer really boils down to 3 major hurdles. First up, geography. You have to be in the right spot, a place where that heat is close enough to the surface to actually reach, which is usually near the boundaries of tectonic plates. Second, the cost. Man, the cost. The exploration and drilling you have to do are incredibly expensive. And third, and this one's a big one, risk. Drilling deep into the Earth's crust can, in some rare cases, have some pretty earth-shaking consequences. And when you look at the cost, the difference is just wild. Back in 2019, the installation cost for geothermal was nearly 4 times what it was for solar power per kilowatt. The drilling alone can eat up over half the entire cost of a plant. That's a massive financial hurdle to clear. And that risk I mentioned, it's not just theoretical. It's very, very real. In South Korea, an enhanced geothermal project injected fluid into the ground. And in doing so, it activated a previously unknown fault line. The result was a magnitude 5.5 earthquake that caused millions in damages and displaced over 1,000 people. So yeah, this shows we have to be seriously careful. But the story doesn't end there. Not even close. Because just as these challenges have seemed almost insurmountable, a new wave of innovation is emerging, designed to tackle these very problems head-on. We are now entering the era of next-generation geothermal. This really captures a huge, fundamental shift in how we think about this. For a century, geothermal was all about finding the perfect natural hotspots. The future? It's about making them wherever we need them. It's a move from being geographically limited to aiming for geographically independent. The key technology making this all happen is called Enhanced Geothermal Systems, or EGS for short. Basically, instead of looking for hot rock that's already full of water, EGS takes hot, dry rock and carefully injects fluid to create a man-made reservoir. All of a sudden, vast new areas of the world become viable for geothermal power. But to create these new reservoirs, you've got to drill deeper and more efficiently than ever before. And the answer isn't just a better drill bit. It's getting rid of the drill bit altogether. Yeah, you heard that right. This sounds like something straight out of a sci-fi movie. There's a company called Quaise Energy, and they're adapting technology from nuclear fusion research, using a device called a gyrotron. It fires a high-power beam that doesn't grind the rock, it vaporizes it. It turns solid stone directly into a gas. And this is where you can really see how all these innovations start to click together. Vaporizing rock lets us drill deeper than we ever thought possible, down to where water becomes supercritical and can carry up to 10 times more energy. At the same time, you've got companies using AI to map what's underground, which slashes the cost and risk of exploration. The results? A huge surge in optimism, with major agencies now doubling their forecasts for geothermal's future. So, what does this all mean? We've seen the immense promise, the really serious perils, and this incredible, game-changing potential. Where does that leave us? At the end of the day, while geothermal isn't some magic wand that's going to solve all our energy problems, it's clearly no longer just a niche player stuck in volcanic hotspots. The convergence of AI, advanced drilling, and new engineering is starting to unlock its potential on a truly global scale. Which leaves us with one final big question. For decades, the immense power of geothermal energy has been just out of reach. But now, with these incredible new tools in our hands, are we finally ready to unlock the clean, constant, powerful energy source that's been waiting right beneath our feet this whole time?